Swayam Prabha. Digital India. Educated India.
So, welcome once again to our discussion on sustainable development, right. We were discussing about sustainable development, and yesterday we said that economists, they define sustainability in two different ways. One is called outcome based approach, where we assume that utility should be non-declining or consumption should be non-declining over a period of time, and if that is ensured, then we can ensure sustainable development also. And second approach is called means based approach or factor of production based approach, where to ensure sustainability we must ensure that means of production or factors of production should be, stock of factors of production should be non-declining over a period of time. Before we come back to today's discussion, I would like to mention as minor corrections in notations what I used yesterday. For non-declining utility, non-declining consumption or non-declining factors of production, what I mentioned yesterday is simply ut greater than equals to 0. That is actually not ut. So, that should be delta ut delta t greater than equals to 0, because without using this differentiation we cannot measure actually the change. Okay. So, this implies non-declining utility, and this implies non-declining consumption, non-declining consumption. And this probably, if we denote capital stock by KT, then del KT del T, this implies non-declining capital stock. So, this is a minor correction I would like to make. And then we said that depending on how do we ensure capital stock to be non-declining or constant, we will get two different rules of sustainability, right. We said that this can be ensured by del KT del T non-declining capital stock. It has two different approaches. The first one, it says that all the three forms of capital, that means K M man-made capital, then K H human capital and K N natural capital should be constant, should be non-declining or constant also, non-declining or constant I would say. And the other approaches said the natural capital should be constant. So, depending on which approach we take, we will get two different rules of sustainability, and today we will take both the rules. So, when we take the first one, the first approach is called, when we say the stock of three forms of capital, here if you look at, I have omitted that social capital, though it is also an important form of capital because of the measurement difficulty. we have omitted the social capital here. We are considering only man-made, human and natural capital. When we say that Km plus Kh and plus Kn should be constant or non-declining, then that is basically called Hartwig rule of weak sustainability. Hartwig rule of weak sustainability. Which says that Km plus Kh plus Kn should be equals to constant. This is called Hartwig rule of weak sustainability. So, that means the implication is, according to this rule, in the process of economic growth or development, any one form of capital may go down. So, that means the stock of natural capital may go down. That is absolutely no problem, as long as we can replace Kn by Kh or Km, right. Now, the question is, so that means this can go down in case we are able to increase the stock of man-made capital, right. But how do we ensure that when Kn natural capital stock is going down, then man-made capital is going up? Basically, Hartwig says, this particular rule says, the rule of zero net investment ensures Km plus Kh plus Kn equals to constant. For example, every unit of economic rent what we derive from the extraction of natural resource should be reinvested fully into the man-made capital, so that when the stock of natural capital goes down, we will get an additional or equivalent amount of man-made capital to work with. That is the idea. Okay? That is the idea. So, every unit of economic rent derived from the extraction of natural capital should be reinvested in man-made capital, so as to get an equivalent amount of man-made capital when stock of natural capital goes down. What is economic rent here? So, basically it says every unit of economic rent derived from the extraction of natural capital should be reinvested in man-made capital to get an equivalent amount of Km when stock of Kn goes down. Okay, that is the idea. Now, what is rent here? Economic rent. Economic rent is defined as price of the natural resource minus its cost of marginal cost of extraction. Okay, that is basically the economic rent. For example, when we extract 1 barrel of oil, if the price of the oil, market price of the oil is 1000 rupees and cost of extraction. So, cost of extraction, for example, if the P equals to 1000 rupees per barrel and MC extraction is, let us say, 200, then economic rent equals to, so this said that economic rent equals to 1000 minus 200 equals to rupees 800. This is the economic rent, difference between price and marginal cost of extraction, and these 800 rupees should be reinvested in any other form of man-made capital, so that when the stock of oil goes down, then that man-made capital will give equivalent amount of services that we are deriving from oil, right. That is the idea. That is the idea. So, this is called Hartwig rule of weak sustainability. Even though Hartwig rule of weak sustainability, that is quite appealing, because first of all, why this is called weak sustainability? Why this rule is called weak sustainability? This is called weak sustainability because it allows substitution between different forms of capital. It allows substitution between different forms of capital, and that is the reason this Hartwig rule of sustainability, this is called weak version of sustainability. Okay, weak version of sustainability, right. Now, there are, as I said, even though Hartwig rule of weak sustainability is quite appealing, as it allows substitution between different forms of capital, and it does not impose any stringent restriction that yes, we must always keep natural capital to be constant. It has several limitations for its practical implication. So, we need to understand now what are the limitations of weak sustainability as proposed by Hartwig. So, what are the limitations of weak sustainability? Okay. There are several limitations of this weak version of sustainable development. So, let us try to understand one by one. First of all, First of all, substitution between Km, Kn and Km, that means natural capital and man-made capital may not be possible, may not be possible at all. Okay. Even though this weaker version of sustainable development, it says that Km and Kn, they are substitute to each other, that means we can always replace Km, we can always replace Kn with additional amount of Km. In reality, it may not be possible. For example, when stock of oil goes down, stock of coal goes down, then it may not be possible to get an exact amount of duplication or equivalent of man-made capital, and that too within a economically feasible time period. That is also very important. So, substitution between Kn and Km may not be possible at all within a economically feasible time horizon. Why I am saying economically feasible time horizon? Maybe that substitution is possible after 1000, 2000 or 3000 years, we will get additional amount of coal, oil or something else, but that may not be possible within a economically feasible time period within a near future, right. So, that is why we said that what we assumed in Hartwig's rule, that Km and Kn, they are actually substitute to each other, that is why we kept Kn plus Km plus Kh constant. That is actually not possible in reality. Secondly, when we think about substitution possibility between Km and Kn, generally it is assumed a Cobb-Douglas type production function Cobb-Douglas type production function is assumed. What is Cobb-Douglas type production function? That means output is actually a function of, let us say, Km and Kn, where it is assumed that it is alpha Km to the power alpha and Kn to the power 1 minus alpha. This is a CD type production function, and if this is the case, then we know that elasticity of substitution for this type of production function, elasticity of substitution between Kn and Km equals to actually 1. So, you can go back and check from your microeconomics what is the concept of elasticity of substitution, and then you can calculate elasticity of substitution for this Cobb-Douglas type production function, which Hartwig assumed in the context of weak sustainable development, and you will see that elasticity of substitution is actually 1. Now, what is the implication of elasticity of substitution being 1? The implication is, this implies Km and Km is actually a perfect substitute to Kn. So, that means this rule not only allows substitution possibility between man-made and natural capital, it also assumes, by the way of assuming a Cobb-Douglas type production function, that man-made capital is a perfect substitute for natural capital. Yes, to some extent maybe it is possible that we can get some amount of man-made capital by replacing natural capital, but how can we ensure that man-made capital would be a proper substitute or perfect substitute for natural capital, which is quite unrealistic, but that is what is assumed by the Cobb-Douglas type production function assumption in the context of Hartwig's sustainable rule. Okay. So, these are this is limitation number 2.